Hey, Trick Class, I want to show you how Desmos can help with a problem like this where you are plotting an angle based on the radian measure that's given. Now, this is, this is a little thing that I do. You don't have to do this ideally. If you kind of clicked on the Get More Help and View an Example or Help Me Solve This, it would show you kind of how to think through it. But this is just something that I like to do. So this is A. I just think of it stands for angle. If you just put A equals a number, it gives you a slider. And a slider is in Desmos a way to see how something changes as a value changes. So I'm going to make A start off at 0 and make it go to the number that it gives me. So 7 pi. So to get pi, you just write pi, or you can come down here to the keyboard, and then there's the pi symbol right there. It's 7 pi divided by 2. Okay, so that's the value that they're giving me. And on the next line, I'm going to write r equals 1. R equals 1, just r stands for radius. So I think of A as angle, r is radius. So r equals 1 is a circle of radius 1. So if I zoom in on this, you can see there's a circle, and that circle hits all the ones, 1, positive, negative 1. So that is a circle of radius 1. And then what we're learning in this chapter is the cosine of an angle is an x-coordinate on this circle. The sine of an angle is the y-coordinate on this circle. So I'm going to write a point notation. So point notation, you're probably familiar with x comma y as a point notation. Well, the x-coordinate again is given by the cosine of the angle. All right, comma, the y-coordinate is given by the sine of the angle. So if I write that, there's the point. So the cosine of 0, right now the angle is 0, is 1, and the sine of 0 is 0. And what I'm going to do is I'm just going to rotate this. I'm going to drag this over to 7 pi over 2, and we'll see where we end up. So as I drag it, you can see it starts rotating. So we go all the way around once, right? We go all the way around to 3/4 when we get 7 pi over 2. So that is the standard position that we start at. And we rotate all the way to there after going around 1 full time. And if you look at my options, I landed on the negative y-axis. So the only one that has that is A. But notice it also shows the dashed line that I go all the way around. So that's a great way to know where you end up with an angle, what quadrant you end up in, any of that, or what, not a quadrant in this case, an axis that you end up. But just knowing that if cosine is x and sine is y, well, I can write it as a point notation and just either, you can put the number in there. The reason why I did it with a slider was to get that rotate that full, it goes all the way around. So I could have just, just done the cosine of 7 pi over 2 comma the sine of 7 pi over 2, just specifically put the point that they give me in there, and it would give me the xy coordinate of where you would end up. But, that doesn't show me that it rotates all the way around once before it finally stops on that negative y-axis. So anyway, either way would help with this problem. But again, the slider is what makes it to where you can see the full rotation as you advance the slider.